Okay, today's topic of discussion is same, that is average velocity, average speed. This we have discussed, but slightly more, and then we shall move towards the instantaneous velocity and the speed. Okay. See, average velocity, as you know, it is displacement upon time, that is delta x upon delta t. Okay, its unit is meter per second if you are using meter unit for measuring the distance or rather displacement. And average speed is path length upon time interval, that is total distance covered in that particular time interval will give you the average speed. In that we have to consider whole length of the path. Now this graph I have shown here to show or to explain what is or how we can find average velocity from the graph. Now see, this is a linear graph. So linear graph gives you idea that this is a uniform motion. Position is taken on this vertical axis and the time is taken on this horizontal axis. These positions are given as 20, 40, 60 up to 140 meter. And time is given in second, that is 1, 2, 3, 4 up to say 10 second I have taken. Now this is a linear graph, any 2 points I can take. Now see, one point I am considering here, that is my initial point, any point you can take. Right now I am taking as 4 second as my initial point. Now at 4 second the position is 80 meter. At another time, say at 7 second, the position is 140 meter. So we can say the distance covered by this object in positive x direction is 140 minus 80, that is 60. So AB is the distance covered, rather it will become displacement, okay, because it is moving in one particular direction. So displacement is 60, that is final position 140 minus 80, that is initial position. So 60 divided by time interval for that displacement, it is 7 minus 4, so it becomes 3. So 60 divided by 3 will give you 20 meter per second. This is your average velocity. Try to understand average velocity. You can take any 2 point, because it is a straight line, the answer of this will be same. So in this kind of graph, if the graph is linear graph, it shows uniform motion. In that linear graph, if you find this AB upon BC by taking points here and here, or you take point here and here, wherever you take, the answer will be same, and that answer is known as the slope of the graph, which is AB upon BC, that is difference of this say y coordinates divided by difference of x coordinates. Difference of y coordinates divided by difference of x coordinates, or it is taken as tan theta. Sometimes it is, some books are referring it as a tan theta. So if you take tan theta, then it will be always opposite upon adjacent, and that will give you the value of slope for that particular graph. Okay. So if linear graph is there, it is uniform motion, and you can find the value of average velocity by taking the slope. Okay, that is AB upon BC. Sometimes we write ABC that way. Okay. Now, in this particular idea, we have uniform motion, means say for example same distances are covered in same time interval. But when we talk about average speed, then it may happen that the value of speed will be different at different point of time. So this average value does not give the idea that what is a particular speed at a particular moment of time. So the idea of this instantaneous velocity and speed has arisen. Average velocity just gives the idea how fast an object is moving, or it has moved on a particular time interval, in a particular time interval, but does not tell us how fast it moves at a different time interval or at a particular moment of time, how fast does it move? Say for example, you have started from Bhavnagar and you are reaching at Ahmedabad. Say distance is 200 kilometer and you have taken 4 hours. So your average speed is 200 divided by 4 and that becomes 50 kilometer per hour. But you are not moving at 50 kilometer per hour for the whole journey. You may be slightly at say 80 kilometer per hour, sometimes you may be at 20 kilometer per hour, or sometimes you must be steady somewhere in your halt. Okay, so it gives you on an average speed how fast you have moved on a particular time interval, but it does not give, this average value does not give the idea how fast you are moving at a particular moment of time. And for that, this concept of instantaneous speed and velocity has arisen. Now for that, if you want to know, say for example a friend is moving in a car and you want to know that, say he has started at 8 o'clock and you want to know that what is the speed at 9 o'clock in the morning. Okay, then what will you do? You will call him and you will say, okay, now it's 8:59, 30 seconds. You just look into your speed, this speedometer, odometer, and at 9 o'clock, what is your speed? You just tell me. So at 9, he will tell, okay, this is my speed. So that is the instantaneous speed, means you have minimized the time interval. At 9, sharp at 9, you tell me. It means the time interval of measuring the speed is taken too small, or we can say in mathematics, we call it, if the time interval is taken too small, that is delta t tends to 0. The time interval is taken very small, and in mathematics we write delta t tends to 0. Okay, that is very small time interval, then the speed which you are getting will become the instantaneous speed. So V is equal to just this equation only. V is equal to delta x upon delta t. But we put this condition here, V is equal to limit delta t tends to 0. It is written as that. Limit delta t tends to 0. You will study in mathematics. Okay. That is delta x upon delta t. So this whole symbol of this limit delta t tends to 0, delta x upon delta t is taken as V is equal to dx by dt. And this is a mathematical representation that gives you the differentiation or rate of change of position with respect to time. Or it gives differentiation of position with respect to time. It shows differentiation of position with respect to time or time rate of change of position. Okay. Now, for this kind of day-to-day problem, we have this kind of curved graph. Now, curved graph shows non-uniform motion. Okay. So this graph I am taking and trying to explain how this instantaneous speed can be understood. Okay, this is the graph which I have taken. Again, I want to take 2 points. So this point I am taking that shows 2 meter. Okay, at what time? At 3 seconds. So initial time t1 is 3 seconds and position x1 is equal to 2 meter. Now finally at 5 seconds, so t2 is equal to 5 seconds, and at that time the position x2 is equal to 16 meter. So this is a time interval of 3 seconds and the distance covered is 16 minus 3. 16 minus 3, that is 13 divided by 3. So round about 4 point something will be the speed. 4 point something meter per second will be the speed. Now that is your average speed between 5 seconds and 3 seconds. That is the time interval is of 3 seconds. Now if you go on reducing this time interval, then this point P2 will come very close to this P1. This P2 point will come very close. Say you are reducing the time interval, you want to take the value at a particular instant of time, then what should be done? This time interval should be reduced. So this P2 will slightly fall here very close to P1. Now, say this point P2 which is falling here very close to P1, I take it as P3. Then if time interval is made too small, very close to 3 seconds, then this P2 will be very close to P1, which will give you, if you join these 2 points, then this will give you a tangent at this point, say P1. Very close to P1 the point is lying. So that point which you are taking very close to P1, that is say P3, and you join P1, then that will give you the tangent at say point P1. So this will give you tangent at P1, and if you find the slope of this tangent, which is drawn at P1, that will give you velocity at this moment of time, that is at 3 seconds. Okay. Now this whole process, it is difficult to show graphically every time. So we find the numerical method. There is a numerical method to find the instantaneous speed at a particular moment of time. That numerical method is there to obtain velocity at a particular moment of time. Okay, and this mathematical process is called the differentiation, which was again invented by this great scientist Isaac Newton. The whole calculus and the differentiation part was invented by him. So the process which was invented by him to find the time rate of change of position, that is nothing but differentiation, and that differentiation of position with respect to time will give you the instantaneous velocity, or it will give you one equation for the instantaneous velocity. And if you place the value of time in that equation, okay, if you place the value of time at which you want to find the instantaneous value, if you put that value in that equation, then it will give you the velocity at a particular instant of time, that is instantaneous velocity. That part of numerical method we shall discuss next time. Okay, thank you.